Okay, Math 2, we're going to look at some exponential functions. Yesterday we played around with looking at some just kind of intuitively dealing with how percent increases would graph functions. So today we're going to be a little bit more specific about it. First thing we know that exponential functions are exponential because the x is in the exponent. So you can see right here a parent function. This specific exponential function is y equals 2 to the x. You have to have a b value. So in this case, b is 2. A little t-chart here to kind of emphasize some of the things. You can see that if I plug in a 0, right here I get a 1 and I put that on my graph. If I plug in a 1, I get a 2 and I can put that on my graph as well, you can see. If I plug in a 2, 2 to the second is 4, and that is also on my graph. Alright. To go the other direction, if I plug in a -1, we remember negative exponents right here, 2 to the negative first power. You can use your calculator, but we know that ends up being a fraction, ends up being 1/2, and it's right there. I can plug in -2, 2 to the -2 ends up being 1 over 2 to the second, which is 1 over 4, which is right there. And what we end up seeing happening, of course, is that we have, well, before we get there, let's talk about the domain. The domain we recognize is all real numbers. I can choose anything along in here as far as what x is to choose. The range will never, ever, ever get below this line. As a matter of fact, it's never even going to touch that line. So the range is always greater than 0. The y-intercept is clear to see. It's a 1. And the asymptote is a horizontal asymptote. And that's the last thing I wrote there, the horizontal asymptote. Remember, it doesn't actually touch 0, so that tells me there is an asymptote. Okay, we can do transformations with our functions. We're not going to spend a lot of time doing that, but it works exactly the same as all of our other transformations. The k on the outside moves it up and down. H on the inside moves it left and right. The a in front can flip it upside down, and it can also compress or stretch it vertically. Okay. Now we're not going to spend a lot of time doing that with these types of functions, but it does work. So we've got a regular basic function right here. This is y equals 2 to the x again, same as this one. So this is the same function. And I'm going to move it. So you can tell this one's been moved to the left 4. And right here the k value tells you to go up 2. So I take this point right here, the 0, 1, and I move it left 4 and up 2. And then I take the next value right here at 1, 2, and took the next pretty value here, and I just moved them all, did a little transformation. Okay? We're not going to spend a lot of time doing that. Alright, what we are going to spend some time doing is talking about the difference between exponential growth and decay. Growth, look at the function itself. It grows very rapidly. Actually, it grows very, very, very slowly until a certain point, and then it switches and starts growing very rapidly. Over here for decay, it decays very rapidly, and then it kind of levels off and it just decays slowly after that. The way we know the difference between those, the a is always going to be the initial value, which we know is really just the start. Okay, so this a represents the starting point. The b will be what we call the growth rate, and the growth rate we hear is greater than 1. So b, if b is greater than 1, it's a growth rate. On the other side, the a is still the initial value, and b less than 1 tells us what we call the decay rate. Now we're going to look at the growth rate and the decay rate more specifically and what it means. Okay, the growth rate is 1 plus whatever percent you're trying to grow. The decay rate is 1 minus whatever percent you're trying to grow. Okay? And that's going to be the next thing that we kind of check out. Those are very important. Of course, we remember that those are going to be our decimals. I got ahead of myself a little bit. Right here, if I have 4% growth, that's going to be 1 plus 0.04. Alright, 1 plus 0.04, that's the 4% as a decimal, and I add them together, I get 1.04. Notice that is bigger than 1. Try 50%. Alright, 1 plus 0.5 will give me 1.5, so that would show me a 50% growth. Again, notice it is greater than 1. And just be careful with your decimals here. 0.025 is the decimal percentage, and again, greater than 1 shows me growth. For decay rate, it's the other way around. Alright, had some problems there, so we'll skip over this one. 20% decay would be 0.2. So that gives me an 80%. Alright, my decay rate would be 0.80 or 80%. Now it decayed 20%, but 20% subtracted from 100 or subtracted from 1 gives me 0.8. Over here, again, I'm going to subtract that, and you can see that's the decay rate. Alright, we're going to now check out some initial values and decay rates in these 4 equations. Okay, the initial value is easy, that's what we start with. The initial value for each of those is just the A value at the very beginning. Okay, it's pretty easy to find. That's the initial value. Now we're going to talk about the growth or the decay rate. That's the B value right here. What I'm really asking myself is 1 plus what number will give me 1.35? Now this normally happens in my head, especially on growth rate, because it's easy to tell. It has to be 0.35, which is of course 35% growth. Alright, that's the idea on these. Over here, it's a little bit harder because this one I can tell is less than 1, it's going to be decay. So I need to know what percent is it decaying. Some people can see quickly that it's 11% decay. What you can do is you can figure out what formula. You can say 1 minus your decay rate has to equal 0.89. And then just by solving for D, you end up getting 0.11. Alright. We've got a 0.25% growth here. 0.25% growth. And over here, we have a decay, and we're going to say, alright, we're going to say 1 minus what number would give us that 0.045. Okay. If I just do my algebra, subtract 1 from both sides, I find out it has to be 95.5% decay. That's kind of the idea on the decay rate. One last thing to look at, and that's going to be writing equations at the bottom. So if I write equations to represent these situations, alright, first thing I'm going to do, y equals ab to the x. Of course, the a represents my initial value, so it tells me clearly the initial value is 200. Alright, now the b is my growth or decay rate. Now this one says growth, so it's clearly growth. So I write 1 plus 0.045, and of course that is 1.045 raised to the x power. So my growth or decay rate goes right here. Depreciate, the word depreciate means decay. So again I start off, and again I notice what my initial value is. My initial value is A, 21,000. Now the depreciate means decay. So it's 1 minus 0.051. Notice I switched it to a decimal. And then when you simplify that, you get 0.949. Guys, if you got any questions about your work, let me know. We'll see you tomorrow.